Hey team, this is Mrs. Hunter. Let's take a look at example B. So this is another neutralization reaction. And again, I know that because magnesium hydroxide is a base and HNO3, nitric acid, right? Strong acid. And so they will neutralize each other when mixed. Okay, so we always get water, right? Because you have the hydrogen and hydroxide that are going to come together. Ooh. And you know what? Let me leave a little space so I remember to balance. Right, so H plus, OH minus. 1 and 1, so we don't have to do anything. Now, you're probably looking at this and you're like, but there's 2 OHs. We will deal with that when we balance the equation at the end. Okay, let's keep going. And then what we have left over, right, we have the nitrate polyatomic ion and the magnesium ion. So magnesium, which when you look at the periodic table always has a charge of +2, and nitrate, which you've memorized those polys, so you know always has a charge of -1. Okay, so remember crisscrossing those charges, right? If magnesium is +2, meaning it can lose 2 electrons, nitrates gain 1 electron, so I'm going to need 2 of those nitrates for that 1 magnesium. Okay, and then we can get rid of those charges because we've used them to make sure we have a correct chemical equation. Now we can actually balance this chemical equation. So if you like the chart method, like we did earlier in class, you can use the chart method. So 1 magnesium on the reactant side, 1 on the product side, 2 hydroxide. So now we're going to deal with that. There's 1 on this side. Okay, so keep that poly together. It'll help you to think about it. Hydrogen, there's 1 on the reactant side. And again, you're just looking at it separate from the hydroxide. So there's 1 on the product side. And nitrate, group that poly because it's together on both sides. So you have 1 on the reactant side, 2 on the product side. So the nice thing about these is they usually fix themselves. I need 2 hydroxides on the product side. So I'm going to put a 2 in front of that water. So that will give me 2 of the OH group, but it'll also give me 2 of the hydrogens, which is fine. It feels like we're causing a problem, but a lot of times these things fix themselves. So I need 2 hydrogens on the reactant side. So I'm going to multiply the nitric acid, the HNO3 by 2. So that's going to give me 2 hydrogens. It's also going to give me 2 of that nitrate group, which is perfectly fine because now we are completely balanced. So this problem balances out. The final coefficient should be 1, 2, 2, 1. Easy peasy.